Before you watch this, I want to be straight with you about something, because it actually makes this story better, not worse. What Apollo 11 really found on the moon that scientists still can't fully explain isn't a monument, isn't a structure, isn't a signal, and isn't anything hiding in a classified file somewhere. It's something far stranger than any of that, because it's real, it's fully documented on NASA's own public record, and more than 50 years later, with all of our modern instruments and all of our advanced chemistry, nobody has been able to reproduce it in a laboratory or give a fully confirmed answer for why it happened. It came home in the seams of 2 spacesuits, clinging to a pair of gloves and a pair of boots, and the moment it entered the cabin of the lunar module, it did something that still doesn't have a complete scientific explanation. Let's go back to July 20th, 1969. Neil Armstrong and Buzz Aldrin have just completed the first moonwalk in human history. They climb back into the lunar module, seal the hatch, and begin repressurizing the cabin, restoring breathable air after hours spent in vacuum. Once the pressure stabilizes, they remove their helmets and gloves for the first time since leaving the spacecraft. And almost immediately, both men notice something neither of them expected: a smell. A distinct, sharp odor filling the small cabin, one that neither of them had encountered on the surface, because on the surface, sealed inside a pressurized suit and helmet with the moon itself sitting in a total vacuum with no atmosphere at all, there was no way for any smell to reach their noses in the first place. This smell only appeared once they were back inside, breathing cabin air, with lunar dust still clinging to their suits, gloves, and boots, dust they had tracked in with them and had no way to fully brush off given how it clung to everything it touched. Buzz Aldrin described what he smelled as something close to burnt charcoal or the smell of wet ashes left behind after a fire has been doused with water. This wasn't a one-time fluke either. On every single subsequent Apollo landing, astronaut after astronaut reported the exact same experience, independently, without necessarily comparing notes beforehand. Apollo 16's Charlie Duke radioed back to Mission Control that the dust had a strong smell and a taste he specifically identified as gunpowder. On Apollo 17, the final crewed mission to the moon, astronaut Eugene Cernan remarked that the cabin smelled as though someone had just fired a gun inside it. And that same mission carried Harrison Schmitt, the only professionally trained geologist ever to walk on the lunar surface, whose testimony carries particular weight precisely because he was the one Apollo astronaut most qualified to notice if what he was smelling had any obvious geological explanation. Schmitt confirmed the same impression, spent gunpowder, and even timed it, noting that his first comment about the smell came almost exactly 7 minutes after the cabin began repressurizing. Here's where this stops being just an interesting anecdote and starts becoming an actual scientific puzzle. Gunpowder, modern gunpowder specifically, is made from nitrocellulose and nitroglycerin, organic compounds built around nitrogen, carbon, hydrogen, and oxygen in very specific arrangements. Lunar dust contains absolutely none of that. It's composed primarily of silicon dioxide glass formed by relentless micrometeorite bombardment over billions of years, along with minerals like olivine and pyroxene, containing iron, calcium, and magnesium. Chemically, lunar regolith and gunpowder have essentially nothing in common. And yet, astronaut after astronaut, independently, across multiple missions, years apart, reached for the exact same specific comparison. Not smoke, not sulfur, not burning plastic or metal, spent gunpowder specifically, consistently, mission after mission. So what's actually causing it? Here is where the real mystery deepens, because the most direct way to solve this would simply be to test the lunar samples themselves. NASA has hundreds of kilograms of lunar material sitting in the Curation Laboratory at Johnson Space Center in Houston, preserved from every single Apollo mission. And when researchers open those containers and smell the material directly, today, the dust doesn't smell like anything unusual at all. Gary Lofgren, a NASA geologist who has spent years personally handling this material at the Lunar Sample Laboratory, has said plainly, after smelling the actual returned samples himself, that they simply do not smell like gunpowder. The astronauts weren't hallucinating, and they weren't imagining a shared cultural association. But whatever they experienced in that cabin, in those first few minutes after repressurization, doesn't exist anymore in the material sitting in storage on Earth. The leading explanation for this involves something specific to the moon's environment that Earth simply doesn't share. Earth has weather. Wind, rain, and flowing water constantly grind down rock and soil over time, a process called weathering, which gradually smooths surfaces and allows exposed minerals to chemically react with the atmosphere and moisture around them at a slow, steady pace over thousands of years. The moon has none of that. No wind, no rain, no atmosphere at all to carry weather of any kind. Instead, the lunar surface is shaped by an entirely different, much more violent process. Constant bombardment by micrometeorites, tiny fragments of space debris striking the surface at extremely high speeds, continuously fracturing rock into smaller and smaller, jagged, glass-sharp particles. Each time that fracturing happens, it exposes fresh mineral surfaces, and those surfaces contain broken chemical bonds, connections that would normally attach to oxygen or water molecules almost instantly here on Earth, but that, in the complete vacuum of the lunar surface, have no oxygen or water available to bond with at all. Those broken bonds simply sit there, exposed and chemically unsatisfied, for however long it takes before something finally reacts with them, potentially years, centuries, or considerably longer. Jack Schmitt himself proposed exactly this explanation after returning from Apollo 17, suggesting that what the astronauts were smelling was essentially the sensation of those long unsatisfied chemical bonds. Finally, rapidly reacting, the instant lunar dust met the oxygen-rich, humid air of the repressurized cabin and the moisture lining the inside of the astronauts' own noses. It's a genuinely compelling theory, one that fits everything we understand about how differently the lunar surface has aged compared to Earth's. But here's the problem. It has never been formally confirmed because nobody has ever been able to actually test freshly exposed lunar dust reacting for the very first time under laboratory conditions to directly observe and measure exactly what that reaction produces. And the reason for that gap is almost as strange as the smell itself. Apollo astronauts carried special sealed containers specifically designed to preserve lunar samples in a vacuum state, exactly as they existed on the moon's surface, protecting them from any contact with Earth's atmosphere until scientists could study them under fully controlled laboratory conditions. But lunar dust turned out to be far more aggressive than anyone anticipated. Its jagged, glass-sharp, never-weathered particles physically cut into the seals of those containers during handling and during the 3-day trip back to Earth, allowing small amounts of oxygen and water vapor to leak in well before the samples ever reached a lab. By the time researchers finally opened those containers, the dust inside had already been exposed to Earth's atmosphere, already reacted, already, in the language researchers use, been pacified. Whatever chemical process actually produced that gunpowder smell had already run its course quietly inside a sealed container somewhere between the moon and Houston, completely unobserved and unmeasured. Which means the only true, direct, first-hand witnesses to that specific chemical reaction, the one happening the instant impact-shattered lunar dust met oxygen and moisture for the first time in over 4 billion years, were a handful of astronauts, standing in a tiny depressurized cabin, using nothing more than the human nose as a scientific instrument. No sensor recorded it, no spectrometer measured it, no sample was ever tested in that exact, pristine, freshly reactive state under laboratory scrutiny. The single most direct piece of evidence humanity has ever collected about how lunar dust behaves in its truest form exists only as a memory, described in radio transmissions and post-mission interviews by a handful of people who happened to be standing there when it happened. Other theories have been proposed over the decades to try to fill that gap. Some researchers have pointed to trace sulfur-bearing minerals within the lunar regolith as a possible contributor to that specific burnt smell. Others have suggested a role for volatile compounds implanted directly into the surface of lunar dust particles by billions of years of constant solar wind bombardment, charged particles from the sun embedding themselves into exposed grains, potentially releasing trace gases the moment those grains are finally warmed and exposed to atmosphere again. None of these explanations has been definitively confirmed, and researchers today are honest about that uncertainty. The evidence that would settle the question conclusively was lost in transit, chemically speaking, somewhere on the journey home. This isn't just a curiosity either. It has real practical consequences for how NASA is planning to send astronauts back to the moon under the Artemis program. Lunar dust's extreme physical reactivity, its jagged, uneroded, glass-like structure, and its demonstrated ability to physically damage sealed containers designed by trained engineers all point to a genuinely difficult problem for any future long-term lunar mission. During Apollo 17, Jack Schmitt developed nasal congestion and other symptoms after exposure to lunar dust that tracked into the cabin, a reaction some at the time jokingly called lunar hay fever, but which researchers now take seriously as an early warning sign. Because lunar dust particles are so sharp and chemically active compared to the smoothed, weathered dust we're used to breathing on Earth, sustained exposure during longer future missions could pose genuine respiratory health risks, potentially similar to industrial lung diseases caused by exposure to sharp mineral particles here on Earth. Solving the mystery of exactly what makes fresh lunar dust so reactive isn't just about explaining an old astronaut anecdote. It's about understanding a genuine hazard that engineers will need to account for before anyone spends extended time living and working on the lunar surface again. So that is what Apollo 11 really found on the moon. The discovery that scientists still can't fully explain more than 50 years later. Not a structure, not a message, not anything hidden from the public, something far more grounded, and honestly, far more interesting once you understand it properly. A form of matter so fundamentally untouched, so completely unlike anything that has ever existed on the surface of our own planet, that the simple act of bringing a few grams of it back inside a pressurized cabin produced a chemical reaction intense enough for two of the most disciplined, highly trained test pilots in the world to immediately, independently reach for the same specific, visceral comparison. Spent gunpowder, a smell that existed for a few minutes inside one small cabin, changed forever the moment it met our air, and vanished before any instrument on Earth ever got the chance to properly study it. Every Apollo mission after that reported the same thing, and every single sample brought home to Houston, no matter how carefully sealed, arrived already changed by the very journey meant to preserve it. Somewhere in that gap between what those astronauts smelled and what modern chemistry has been able to actually measure, sites a piece of lunar science that 50 years of Earthbound laboratory work still hasn't fully closed. And when astronauts eventually return to the lunar surface under the Artemis program, kick up that same ancient, unweathered dust and climb back into a pressurized cabin, there is a real chance they will get to answer, with modern instruments finally in the room at the right moment, a question first raised by Neil Armstrong and Buzz Aldrin, standing in a tiny metal cabin, 12 stories above the surface of another world more than 50 years ago. If stories like this, the real quietly unresolved mysteries sitting inside missions we think we already fully understand, are what you come here for, stay close, because there is more waiting in the archives, still unexplained.